Okay, part three. Oh, bathroom again. Shit, dude. All right. Oh, excuse me. Oh, cold chair, cold chair. All right. So if it doesn't make sense to call a function with a specific type, we can create an overload and then delete that bitch to prevent calls with that type. What would be a good use case? I mean, the standard character thing would make sense. You wouldn't want to do it like, oh, hey, fucking input a name for the character and you have to pass it a string and then you create an overload to rule out an int or something. Like, do it for something that is going to be ambiguously. And an int probably doesn't even convert to a string anyway. But in the event it does, whatever, your name's one. But when there's some sort of problem wrong process that we're trying to, or pathway that we're trying to handle, I mean, I can see it with conversions going on. It seems like that would have to be it, because if you're calling a function and it's valid, either you called it with the type that it has in its definition, you called it with an argument that matches the type of its defined parameters, excuse me, or you called it with arguments that can be converted to those types. That's it. Anything else will be wrong. So if I pass, like, what even happens if I take a string and then I okay, and then what happens if I call print thing with one? Yeah, so there's no. So in the type of a string, there's no way to convert an integer. Or at least, I don't know about this constructor shit. It seems like that's an object thing, because in classes there are constructors so that when you call it, or when you create an object, it calls the constructor, I think. So does that mean that there's a class called, or a, is it a class? I guess it is. There's a class called standards, or there's a class called string within the standard library. And when I create it, it has different possible conversions, and the constructor is what does those conversions. But there is nothing in the constructor, there's no suitable constructor. You might have multiple constructors, sounds like. One for this, one for that, one for this. Nothing to convert an int into a standard string. So we would have to handle something where the conversion is valid, but that we don't want. I mean, we did that for an unsigned int earlier, so maybe you're manipulating something in memory and you want to rule out any calls to it with a regular int. We only want unsigned ints. Or we could say apply damage. What the fuck? What the? I don't even know. I don't know what happened. We avoid apply damage, and it takes an int damage, and then it does something. I don't want to give it an unsigned int, because if I give it an unsigned int, the unsigned int can be a value that is so large that it can't fit inside the int, which means the int would become negative, and we would be doing negative damage. I mean, really, we would just have a check to see whatever the damage is. If it's negative, no damage. So the lowest it can be is 0. And we could just say unsigned int, delete. So we can call it with 3, But if we call it with an unsigned int, no sir. Plus, anyways, we would already get, never mind. We're not getting an unsigned, oh, it's because, I'm telling you, the IDE is smarter than learncpp.com says, because it says that, hey, this shouldn't compile unless, oh, never mind, it's fine. The reason is because this is a constant expression, therefore the compiler is able to check. Just like if I had an unsigned int test and we made it 3, and we pass in test, we get an unsigned signed mismatch. But if this guy is const expression, then we're cool, because the compiler will evaluate him first. See that? Fucking knowledge, yo. Alright. We define the function as deleted. Yes, if the call matches, then we halt. It's not all calls to the fucking function. It's to the deleted one. It's to the overload. We don't want to just delete one function. We want to just prevent invalid, or we want to prevent valid but wrong, incorrect, valid calls. Or valid but incorrect calls. Dude, there's another pimple action on my neck. It's like it's in the hair or something. It's like on the line of the hair on my back of my neck. Okay. So in this case, we have int x is the parameter for print int. So we can print an int. Cool. But we have overloads for character and Boolean parameters, and those are deleted. So if we call it with a Boolean or we call it with a character, well, we get a compiler error that you're referencing a deleted function. So it prevents calling the function with valid but incorrect or unwanted arguments. I was going to say signature, but okay. Oh, and if we call it with 5.0, a double has to be numerically converted to both of those. And same for an int, so it's actually ambiguous in this case, because we are not explicitly deleting it, and it's ambiguous, because it actually matches all 3. Yes, it's a numeric conversion for all 3. Which is interesting. I'm surprised. Well, I mean, it's saying it's valid, so the ambiguity takes priority over the actual call. So it says, you try and call the function, and it doesn't go and look in the definitions first and say, hey, are all these guys defined, by the way? It says first, is your call okay? I don't say, oh, hey, I'm the bouncer, you're coming into the club. Who are you trying to talk to? First, I'm going to give you a little shakedown to see if you should be coming in at all. I don't give a fuck who you're going to try and talk to. What are you wearing right now, buddy? You better be wearing some crazy shit to get in this club. So the compiler's saying, hey, oh hell no, you're wearing some crazy shit. Even though you're trying to talk to someone who doesn't actually exist, this is just a forward declaration. There is no definition for this signature specifically. You can't get in my club. Same thing with your Boolean ass over here. Nope. Just a signature. It's not defined. It is declared though, and it's deleted, so it's valid. It's valid to the compiler. So the doorman is active. You're not getting in, buddy. Okay, and same thing here. So ambiguity and deletions. When you have a fucked up call, those take priority before you finally actually call the thing. We don't look at definitions until the call is good to go. Not ambiguous, and you're not referencing some deleted shit. You're not calling a deleted function. Yeah, there's a good little thing here in a second. It's a direct match, which is deleted, therefore we get an error. Print true is a direct match as well. Deleted, another error. Print 5. Why would it be unexpected? Oh, I guess you're thinking that, hey, it would call print int, well, the int parameter one, because the others aren't defined. but first it checks to see if there's print double. It does not. Next it tries to find the best match. It's not deleted. It's the only one that's fucking defined. Even so, the deleted ones are still candidates because the compiler is the one, he's the doorman. He gets to check. It's not the linker. We don't give a fuck about the linker right now. Okay, makes sense. Delete means I forbid this, not this doesn't exist. It's not that we're removing or deleting a function. We are forbidding calls to the function. Should just be function signature is no, not is delete, but whatever, it's fine. Equals delete. Deleted functions participate in all stages meaning that you can have, well, yeah, exactly. Same thing here. So, if they only participated in the exact match stage, then print 5.0 wouldn't even look at the other two. There wouldn't be a match. Therefore, print int via numeric conversion would be the match. But no, they participate in all pieces. So even though they're deleted, the compiler is still going to try and convert 5.0 via the steps to see which one gets called. Yep. And a deleted function can be selected. So we could have the deleted function for an int, or the int overload has delete. And then the other functions are like character and boolean, and I call it with a short. Well, a short is going to be promoted to an int before it's going to be converted down to a boolean or a character. Therefore, the deleted int version is actually the one that gets chosen. So then it's deleted, it's not ambiguous. Ambiguous. Okay. Other types can too. So you could have a member function. Oh, just like in the character input object, or in the, yeah, I guess the CIN, standard SYN. Dot ignore, it has an ignore member function. As it has a clear member function, it has an EOF member function, and all of these could be deleted. So I could, if I included IOStream and then had standard character input as a class, I guess, and then went to its member function and I declared it. Well, I guess I don't declare it. You just declare. I don't know how that works. How. If I have a CVP file that defines a class that I can use to create instances, objects, do I have to forward declare the whole thing? And the member functions are just forward declarations? If they are, and I included IOStream, that has definitions though. I mean, maybe it's just forward declarations, but it could also be, I don't know if they're inline definitions or if they're forward declarations. If they're forward declarations, the shit exists elsewhere. That means I'm just including forward declaration 1. And then if I do another forward declaration for character input dot ignore equals delete, then I will get that same compiler error that says, hey, you can only delete functions in the first declaration. But if it's a definition, then I think it would say that there's already a body. I think that's what was happening. If it's already defined in here, if we say would do thing okay, and then we say void do thing this, or hold on. Yeah, it'll say it already has a body, exactly. So if it's defined, oh, so yeah, so if it's defined in the file, it's declared, so we can't delete it after the fact. We can basically only do that. We can only do that in the first declaration for a function. And we can't do it for a definition. So if a function's defined in a file, we can't delete it in the same file. So if we were forward declaring a class, I think the member functions could have an equals delete next to them. That way, we could try and call them, and we would get a compiler error. Hey, character input dot ignore is a deleted function, but we can't do that because if I include IOStream and it's a for declaration, then we're deleting it in its second declaration, which doesn't work. And if it's a definition, then it already has a body, which means we can't do it. It's still kind of the same reason. Okay, we discussed deleting member functions soon. Constructors. Oh, is the copy constructor deleting member functions? That must be it. That's like when I call when I call a MRSA, or when I define a MRSA and twister and I seed it with something, I'm seeding an object. So the object is doing something and has logic specifically saying to do something with these values. I think it has multiple properties that are its seeds 1 through 8 or 0 through 7, 8 of them. And when I seed it with a standard seed sequence, each of those guys goes where it should and matches its respective seed, its parameter. And I think the copy constructor takes effect there. When I call an object, the copy constructor describes how the parameters are given values from the arguments. It may always be copy. I don't know. Because I think the strat is that this object gets some area of memory, it creates its parameters, and initializes them via copy assignment, so copy initialization, which doesn't catch narrowing conversions, by the way. Copy assignment from the values of the arguments you have. So the arguments are evaluated, and those values are copied over. Okay. deleting function template specializations. Soon. 3 lessons. We have 5, 6, 2 more after this one, and then boom. Template instantiation. Okay. Template specializations, meaning if you have a function that has some sort of template parameters, I guess, that way it can accept and do specific shit depending on what it gets. Well, if you don't want it to be callable for certain types, then maybe that's what you do. So you have I don't know what that would look like. I don't know if that's in a single definition of a function, a single function definition, where you do that, for where you do template shit. Hey, if it's an int, do this. If it's a string, do this. If it's a this, do this. Or if it's in separate overloads. I mean, I don't think it would be the overloads, because it seems like that would be the same shit as just regular ass function overloads, where the most matching, the best match overload gets called. I think the template would be one function, and if you want to restrict calls to it to have these types of arguments and not those, then you can delete the template specializations, the specific type, the specific data type that is being called for the template. Delete all non-matching overloads. Oh, all non-matching meaning those that just aren't an exact match. So like if we had print, or we had yeah, sure. If we had print thing and it took a float and I called it with 3.0, it would fail because 3.0 is a double and that's not a match. Well, yeah, if we wanted to remove all of those and only call it with a specific type, that way we don't have any rounding errors or anything. Like maybe we have a function that we call to update the time, and somehow there's some number that we're pulling from to update it. And I only want that number. And maybe there are some other similar numbers that are similar in value, but they're different types. And I don't want those calls because those are going to fuck it up. I only want this one. So I only want an exact match. I only want doubles. I don't want ints that get numerically converted. I don't want floats that get numerically promoted. I don't want anything like that. And I only want it in this range. I don't want anything too high either. I don't want long doubles. Only floats. That's it. Then maybe we have something that's like, if it's not this, then delete or something. Excuse me. Yes, it would be verbose because you'd have to have a prototype that's deleted for every single type you're not trying to accept, or every single signature that you don't want, or that you want to disable calls for, or calls to. Only with ones that exactly match. And we can do it with a function template. Oh shit. Default arguments. Oh, that's like I think we have to do copy assignment for that. Or can it be, so what are the different types of initialization? There's default initialization, which doesn't assign anything. It just leaves it a garbage value. There's copy initialization, where we copy a value from here to here. We have direct initialization, which is parentheses. We have list initialization, which is parentheses. We have direct list initialization, I believe, which was equals parentheses, or equals braces. So there's braces and then there's equals braces. And I don't know if that flags as narrowing or not because it's copy assignment, but with the braces, so maybe, I'm not sure actually. Yeah, I don't know. And then there's value. So there's default, there's list, there's default, there's copy, there's direct, there's list, there's copy list. Maybe it had a specific name, a special name, and then value. Okay. And if that's the case, we can say print int x. And so if we have a function and we do an overload and we do some type shit, something with a template, we make an overload that is the template, and that template is only chosen if there isn't a direct match to the arguments. And there's no, I don't know if you can pass a type name to something, a literal, like a template to something. If you have to pass something of a specific type, like a value probably has to be of a specific type. But maybe a data type is of type name, I'm not sure. Or keywords are of type name, I'm not sure. Or like keyword data types are of type name. Yeah, I mean, it seems like type name is a class. So, if we pass in a direct, just a straight up int, this guy takes precedence. The templates kick in when there isn't anything direct. So I could have apply damage for an enemy, and the character might have different types of damage that he can do, and some of them might be integers, and some of them might be floating points. By default, we could say it's floating point, okay? And we could have a function that takes a floating point parameter. But then we could also have a template one that does shit for the rest. And maybe that's different. Maybe those have a little standard character output beforehand that says, hey, this requires conversion. Boom. This is not the default call. This is the backup call. So you could have like yeah. Okay. Just thinking about stuff in a game as functionality, like if you're pulling a lever with a certain code and it doesn't work, then you have your backup code, and then it'll say, hey, this still works, but by the way, it's backup. But in this case, you can't literally make that one-to-one because in the compiler, it literally won't compile if the shit doesn't match. So in this case, we then take template type name T. And so we're creating a template. And do we call the template, is the template called T? How is the template, because if I had another template and called it type name X, and so this is a so this is, we're like defining a type name here. We're defining a template and substituting the template for the type name. That way when we pass it, the template will take the type and do whatever the specific shit is. But I wonder how you get functionality for specific types. So do we say, if T is int, do this. If T is this, I don't know. I mean, it'd be cool. And then this would be cool because we don't have to fail input. We could say, hey, we're passing the wrong kind of value. Create a variable of that. I wonder, could you create a variable of it? Like T X is a variable called X of type T, and we don't even know what it is. And we assign it to be this, and maybe it matches, but then maybe you'd have to have auto. I guess you could do auto there for the type deduction. And then if it's this, print an error. If it's this, do this. It's interesting. Function templates, only one chapter away. Or one chapter, I guess, or lesson. Template type name T, and then we have print int T and then some variable. I don't like that we're doing x here, but fuck it. I mean, in this case, it's almost more straightforward to just say, hey, print int this. Oh, well, it needs an identifier for us to actually access it. And I guess you could keep x in here. I almost kind of don't want x in here. Just because we want to exclude all other type names. And type name could be an int. But if you call it with an int, it's not actually going to trigger. Due to I wonder where template is later or in the hierarchy of conversions, because exact match is number 1. But, so template has to be somewhere else. Template type name T. And type name is one word, no camel case. Interesting. So we could say int main void do thing, or just say, yeah, do thing. And then we can have template type name T I think it needs to be a statement. Do thing in parse. Oh, unrecognizable. Type name T. Fuck. Did I already mess it up? No, it's good. Oh, I did. Yes. So it doesn't want this to be here. And maybe right after I have to say it specifically. Oh. If I remove this, then we're cool. But if I put this template thing in, it's thinking that main is taking this template. I think the template might affect the thing after. Provide sample template arguments. I'm not sure. What if I did this? Oh, no. Don't want that. And then we say void do thing T. So if we call it with nothing, we're cool. And now we're saying, hey, if you call it with anything that's not nothing, done. So we can say do thing. But if we say do thing 5, no, it's deleted. We can say yo, no, he's deleted. These are all deleted. This template type here has all the other possible types. With T as an int, can't be referenced, so it's declaring all the other versions. So there's all these possible versions. We want this one. We define this one. Cool. Declare the rest. Delete. How do we declare the rest? A template. A template can be converted to any of the other types via type name. But if we say do thing normal, then we're cool. So we could say, what happens if we say template type name T? Well, we can't define shit here. Excuse me, yeah. Seems right. A template declaration. Not allowed here, buddy. Void do thing. We could say void apply damage, and it must be an int damage, and then it does something with damage. And then we have template type name T, and then we can have void apply damage T damage. Delete. Only want calls with integer. Calls with integer with int argument. And then we could say apply damage 5, we're good. If we say 5 point, what happens if we do 5 point? Oh, you don't even need 0.0. Interesting. I didn't even know that. Okay. If we say a big ass integer, still no. That's a fucking int64, buddy. What happens if we remove 2 of these and another 2? We're cool. Okay, so it does go from, I don't know the purpose of a long. Seems like it might be a long and it might not. I don't know. I'm not really sure. I don't know. I don't understand. Okay. I mean, I guess it could be, maybe it's a more efficient way of an int64, so instead of saying, hey, you have all these fucking zeros that aren't being used and taking up all this space, instead, your size is determined by your initializer. Maybe it's cool? Okay. All right. Default arguments. A default value for a function parameter. Why the fuck are you doing y equals 0 like this? Or y gets 0 like this? Oh, you can't do that. Or does this set both? This and this? Is that what happens? Oops. Oh. Oh. It only wants one of them. Oh. And then we call it and it says 1 and 10. What if I call it with 1 and 200? Oh, it gets overwritten. So this is the default argument and we pass shit to it and it gets overwritten. So could I do x equals 30? And by default, so what happens if I, oh, so if I could call it like this, and by default it's 30 and 10, but I can overwrite it. Oh, when would I want that? I mean, I guess you could just create I mean, I guess it's a more, a case where you need to default to something unless you specify it. So can I do this with a standard string? Can I say like, hey, I'm in a space game and this function is get time and you have to pass it the planet of the time, or yeah, let's say it's like the planet-wide time. There's some global time the whole planet has. Whatever it is. Universal time. Every planet has it. And I'm in this other fucking galaxy. Well, if I just call print time, humans are from Earth. By default, the standard string defaults to Earth. But I can call it with another one and pass that. So what if we do include string and we say void get time, standard string planet is Earth. Fuck. Oh wait. Oh! Oh my. Oh. Oh, well, this wouldn't, well, and then we would have something saying, if planet is Earth, this, if whatever the fuck. And by default, it would do Earth. Okay, alright. Self-test time.